In this lesson, you are going to learn about the rational zero theorem. This theorem looks kind of crazy, right? Look at this right here. They're giving us just an example of a polynomial. So what's happening here is this is our degree here, right? And they have all these a's. What does that even mean? An, is that from our chapter 11? Remember, summation notation or something like that? Doesn't that like crazy, like, oh, recursive formula? Remember doing stuff like that? So when you look at this formula, I think you should look at it and say, oh, I have no idea what this even says. So instead of explaining that first, I'm going to talk to you about what they're saying with this formula because I think that makes more sense when you're first learning it. The rational zeros of f of x. So rational zeros mean numbers that aren't imaginary, right? We're going to find some actual numbers we can use. So not irrational numbers, numbers that go, so they're real. First of all, rational numbers are real, right? And the options between real are rational, if we're going to break them apart, and irrational numbers. An example of an irrational number is pi or e. And so we're just looking at rational, meaning they are numbers that could be decimals and fractions, but they have to end. They can't repeat and go on forever. Okay, that's what a rational is again. So to find the rational zeros, you find p over q. Now what's p over q? I'm going to show you in a minute. So right now you can be like this. What's going on? If I show you your first problem, I think it'll make more sense. So here, to find all the possible zeros of this equation, f of x equals 3x to the fourth minus x cubed plus 4. We list the factors of this is called q and this is called p. And remember from the other page we had p over q. Okay? So q is the coefficient on that first term there. So the coefficient is 3. We're going to list the factors of 3, which are 1 and 3. P is our constant. So our constant is 4. I list the factors of 4. It'd be 1 and 4, 2 and 2. But I don't double things up, so it's going to be 1, 2, and 4. I like to list them least to greatest. You may do something different, but that kind of works for me because right now I need to find all the possible zeros. So I have to take p divided by q. So I start with my first p of 1. 1 divided by 1, and I'm going to not put this in the box yet because I wait till I put my answer there. 1 divided by 1 is here, and then I do 1 divided by 3. See where I'm getting that? Then I'd go, this is done, I'd go to the 2. 2 divided by 1, and 2 divided by 3. Next, I go to the 4. 4 divided by 1, 4 divided by 3. So when I look at these are all my options here. I want to reduce them as far as I can, so instead of like 1 over 1, I'm going to actually write 1. 1/3 reduced, 2 over 1 is 2, 2/3 reduced, 4 over 1 is 4, and 4/3 is reduced. If there were any that repeated, I would only use them once. This problem doesn't have that. The other part of it is, though, I use the positive and negative value for all of these. So it's going to be plus or minus, 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 plus or minus. So I would like you to list your answers least to greatest. So my least is plus or minus 1/3. Next would be, go comma, plus or minus 2/3, right? Then I could go plus or minus 1. And then 4/3 is smaller than 2, so plus or minus 4/3, and then plus or minus 2, right? Cross those out. There's my 2, there's my 4/3, and all that's left is my plus or minus 4. So, what does this mean? Of all of the factors that might be solutions to our equation, so our answers to this problem if I was to solve it, our roots, our zeros, our solutions, our answers, whatever you want to call it, these are all my options. I started with infinite numbers. It could be any number we could think of that could be the answer to a problem, right? And if I can't factor it, which I can't factor these, right? I have to look at this and say, okay, now what should I do? Here's your option. So you went from having infinite options to having the 6, and since it's plus or minus 12 options. So we went from infinite options to 12. Now 12 seems like a lot of options still, doesn't it? I mean, it kind of feels like you're going to be doing stuff forever to find which of the ones it is. But 12 is much better than an infinite amount. Okay, tomorrow we're going to actually, or in our next lesson I should say, we're going to actually use these. So for now I want you to be able to find them, and tomorrow we'll explain a little bit more about how we would use them. So the last one we're going to do, there's just going to be 2 of them today, is this problem right here. So 4x to the 5th minus 2x plus 18. So I list the factors of 4, which I just did, so that I know that's 1, 2, and 4. When I list the factors of 18, holy buckets, 1 and 18, 2 and 9, 3 and 6. So if I put them in order, 1, 2, 3, 6, 9, 18. So now I'm going to take P divided by Q. So I don't like to use my answer box, so I always do this on the side. So P divided by Q, let me do this again. Okay, 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. Okay, this one's done. Next, I'm going to go to this 2. 2 divided by 1 is 2. 2 divided by 2 is 1. Oh, I already have a 1, don't I? Well, we'll skip that later. 2 divided by 4 is 1/2. Okay, that one's done. I'm going to go to this 3. 3 divided by 1 is 3. 3 divided by 2 is 3/2. 3 divided by 4 is 3/4. This one's done. 6. Coming down over here. 6 divided by 1 is 6. 6 divided by 2 is 3. 6 divided by 4 is 3/2. Done. 9. 9 divided by 1 is 9. 9 divided by 2 is 9/2. 9 divided by 4 is 9/4. And lastly is 18. 18 divided by 1 is 18. 18 divided by 2 is 9. 18 divided by 4 is 9/2. So now when I look at this list, I don't have any repeats, so I can cross out this 1, this 1/2, this 3, this 3/2, and this 9, and this 9/2. Does that look like what I can cross out there? So, and I would notice if I had to list some twice here as I go least to greatest. So my smallest number up here I think is 1/4. So I'm going to go plus or minus. Remember on all these, you got to add that at the end. Plus or minus. I don't put it in here because I think it gets really messy and it's harder for me to see them. So 1/4, then my next smallest number would be 1/2. Any other numbers less than 1 up here? How about 3? Nope, not 3/2, not 3/4. Oh, 3/4, yeah. Plus or minus 3/4. So that one's done. And then all my other numbers are bigger than 1. So I'm going to go to 1 next, plus or minus 1. Now I'm looking for numbers that are less than 2. So 3/2 is less than 2. 9/2 is really 4.5. I'm just going to write that in there. 9/4 is 2 and 1/4. That'll help me out, right? So I only have 3/2 next. Plus or minus 3/2. Then I'm going to go to 2. Plus or minus 2, and then anything between 2 and 3, right here I have 9/4, plus or minus 9/4, and then I go to 3 next, plus or minus 3, and then anything between 3 and 6, between 3 and 6 would be this 9/2, plus or minus 9/2, and then I have no other fractions, so I can go with my integers, plus or minus 6, plus or minus 9, plus or minus 18. So 6, 9, 18. That's all of them. This is a long one, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 12 times 2 because of the plus or minus. I have 24 options here. That's a lot of options to try. It'd be really mean for me to give you one like this in a test. Those are my options for what my roots are. In our next lesson, we will see how we apply this. So we're going to be using this in our next lesson. For now, you just have to be able to come up with these. If you have any questions, make sure you let me know tomorrow.